All right, continuing where we left off, we are now using 4 midpoint rectangles, it says right here. So what we want to do is maybe get a basic graph going over here. Very basic graph, like don't work too hard. The cross is at 3, so that'd be 3 right there, and it's got a positive slope of 2, so it looks something like that. And then we know we're going from 2 to 6, so I'm going to mark off 2 here, that would be maybe 4 over there, and then maybe 6 is over here. And it says 4 midpoint rectangles. In fact, I'm going to make that a little bit wider. We'll put 6 over here a little bit further out. Okay, so what we want to do is first off find out how wide these need to be. So the entire width of the interval is 6 minus 2, that would be 4. But you're going to have 4 rectangles in there. That's going to get 4 over 4, which means the width is 1. So I'm going to go over to 3 and 4 and 5 and 6. Now the trick on this is it's midpoints. So now what we want is in between the 2 and the 3. In fact, let me throw the numbers on here, 3, 4, and 5. Between 2 and 3, that's going to be 1 rectangle right there. But what we want is the height of that first rectangle to be right at the middle of that little subinterval from 2 to 3. And then we'll do it again. Let me pick a different color here. So right between 3 and 4, that would be the height right there, and then we'll have a rectangle here for the second one. So there's your base of 1, and then we'll switch colors again. How about some pink over here? So the height would be here, and those heights are associated with the in-between values. Okay, so specifically there's a 4.5 that we're going to plug in for that one. And there's a 3.5 we're going to plug in to figure out the height for that one, and then of course a 2.5. So continuing with that pattern, we'll have a 5.5 plugged in. Oops, I didn't really need to draw that first part there. There we go. So I think we're ready now. All right, so what we need to do is figure out what are those actual heights. So it's as simple as just plugging in to find out what the actual heights are. So let me go like this, f of 2.5, that's also known as 2 times 2.5 plus 3. And I'll just do a couple of these. That's 5 plus 3, so that's an 8. Okay, so then we do it again, and I'll go ahead and switch colors here. So for the second one, it'll be f of 3.5. And again, we're going to double the x value that's coming in. So 2 times the 3.5, add 3. So this is 7 plus 3 more, so that should be a 10. So we now know the heights. We know the heights. We're looking at a height of 8, a height of 10. So this is the height. This is the other height. All right. Now we know the base. The base is always 1. If you look down here, the base is always 1. So what we're saying is that the integral is approximately equal to, let's see, a base of 1 and a height of 8 plus a base of 1 times a height of 10 plus a base of 1 and a height of I don't know yet, and a base of 1 times a height of I don't know yet. All right. To find these other heights here, you can basically just plug and chug like we did here, but you can also use the idea that the slope of this function was 2. It was sitting right here. It was sitting right here. It was sitting right here. The slope is 2. So if you're going to go from a 2.5 up to a 3.5, that's a run of 1. So then the rise must have been a 2. So that means your heights should have been changing by 2. And sure enough, 8 goes up to 10, 10 goes up to 12, 12 goes up to 14. And if you don't believe that, you just plug in your 4.5 and your 5.5, you'll get the same heights. All right. Ultimately, we end up with a final answer of 44 square units. All right. Now this one, we don't have a curve to it. That was a straight line function, f of x. So that means our overestimating here and our underestimating there, those are actually identical. So this is actually the true area underneath the curve. All right, moving on to number 3. Use left-hand rectangles to approximate this right here. This one's a little more complicated. So for this one, we're going to let the calculator do the work for us. But I do want to start off with at least this part where we decide what's the width. So we're going to go from 20 down to 2. That's an entire width of 18, and you're going to do 3 rectangles. So each rectangle should be 6 units wide. So what we're saying with that, and I don't even know what this function looks like, and I don't really care. We need to get away from that idea of needing the graph. So instead what I like to do is think about my interval. I'm just going to look at an x-axis, and I'm going to call this 2. And I'm going to go over a certain amount and say 8. And then I'm going to go over some more and say 14. And then I'm going to go over some more and I'm going to say 20. And then I'm going to come back in here and I was hoping to erase, erase a little bit of this. Okay, now hopefully you can see how I got these numbers, the 2 to the 8 to the 14 to the 20. I'm using my width here of 6. If you add 6 to the 2, you get 8. Add 6, you get to 14, you get to 20. So what that tells us is these are the x values that we will be plugging in order to find the y values. Now, to be clear, it did say use left rectangles. So if you were to make a little table to go with this, it may look something like this. You have an x and you have an f of x, or g of x, whatever you want to call it. So we're going to go from 2 to 8 to 14 to 20. And now we know we're supposed to be doing left-hand rectangles. Well, that means whatever I plug in over here on the left, this would be ln of 2, plus 3 times 2, which is 6. The next one, I'm going to plug in the 8, ln of 8 plus 3 times 8, which is 24. And again, I'm just using this equation right here. Okay, so then next up, we're going to have I'm going to go at an angle here because I don't have enough space. ln of 14 plus whatever 14 times 3 is, and that's going to be a 42. And then the last one will be ln of 20 plus 3 times 20, which is 60. Now, we need to think about which ones we're supposed to use. You're going from here to here. You're supposed to use the one on the left. Then I go from here to here, 8 to 14, I use the one on the left. Then I go from 14 to 20, and I use the one on the left, which means this guy over here, we're not going to use at all. All right, so there we have it, 1, 2, 3 heights, and it's time to go set up our sum. We think it's going to be approximately equal to the base times the first height. That would be ln of 2 plus 6 plus 6 times ln of 8 plus 24 and plus finally one more base of 6 times the last height of ln of 14 plus the 42. All right, so this right here, this could be your final answer. It's got all the numbers plugged into it. If we don't have a calculator, we would just leave it like that. Now we can simplify some things and move some stuff around. That's possible. One of those things we could do, if you're just looking for a different format, you could factor out the 6 because all 3 terms have the 6. And then what you got left inside is basically, let's see, an ln2 plus an ln8 plus an ln14. That's this guy, and this guy. And then separately, maybe I'll write these in a different color. We got the 6 and the 24 and the 42. So then I could just say 6 and 24 is 30, plus 42 more is 72. And there you have another format of your answer. If you put this in the calculator, you're going to get approximately 464.4699, if I'm not mistaken. Let me double check that real quick. Let's see, it's 6 times the ln2 plus the ln8 plus the ln14 plus the 72. Yes, 464.4698763. So we'll go 4699. Sounds good to me. As far as the AP exam goes, you would have been fine right here, which actually means you would have been fine right here. As long as you got all the numbers plugged in, you are good to go. All right. Okay, moving on to the next page. We're looking at number 4 now. Let's see here. It asked us for 5 left-hand rectangles, and then for part B it says 5 right-hand rectangles. So let's start with part A. 5 left-hand rectangles. First thing you want to do is go find out what's the width of each rectangle. And we're going to go with the high minus the low. Careful, you're subtracting a -2. And you divide by the number of rectangles we're looking for. And that's a 10 over 5, which is a 2. Okay, so knowing that's a 2, we're going to go 2 units from the -2. So -2, if you add 2 units, gets us to 0. If you add 2 units, it gets us to 2. If you add 2 units, it gets you to 4, and then to 6, and then to 8. Okay, and it said 5 rectangles. Here's 1, 2, 3, 4, 5 rectangles being built right here. Now, knowing that they're left-hand rectangles, remember what we said about that. You're going to use the height that's on the left. And then for the second rectangle, you'll use the height on the left. This one, ignore it completely. For this third, this is the first, second, third, fourth, and fifth rectangle. So for the third rectangle, you're going to use the height from the left. For the fourth rectangle, the height on the left. The fifth rectangle, the height on the left. And there we have it. We have all the heights. We'll go approximately, the base is 2 times the height of 2, plus a base of 2 times the height of 3, plus a base of 2 times the height of 1, plus a base of 2 times the height of 2 again, and plus a base of 2 times the height of 4. Working that all out, we end up with a total of 24. Okay, so that's for the left-hand rectangles. I'm going to change colors here for part B, and we're going to do right-hand rectangles. And it does say of equal length. That just means make sure you do the same distance, 2 units. All right, so I'm going to change things up. I'm going to use a different color. We'll use some red this time. So this time, if I'm going 5 right-hand rectangles, we're going to go, this is my first, and here's my first height. Here's my second height, third height, fourth height, and fifth height. So our area will be approximately 2 times the first height, 2 times the second height, 2 times the third, 2 times the fourth, and 2 times the last. You'll notice a different style here. I didn't do parentheses, parentheses. I just did a 2 out front times parentheses. So my first 3 goes in, that's this guy. And then the 1 goes in, that's that guy. And then the 2 goes in, and then the 4, and then the 5. And working that all out, let's see, that's 6, 8, let's see, 4 more is 12, 18 more is 30. Is that right? And plus 10 more, 3, 1, 2, oh, that's a 4 right there. Okay, yeah, that's right. Final answer should be 30. Let me double check that. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you factored it out, it would have been 2 times 15, and that turns into 30 square units. There you go. All right, moving on to number 5. Using right-hand rectangles. So let's start with, oops, don't know what happened there. So starting with right-hand rectangles, let's go with some, how about some green this time? From -2 to 9, 3 right-hand rectangles. Oh, and they told us the interval this time. That's different. So we're going to go -2 to 0, 0 to 4, and then 4 to 9. So we've got a change here. The distance between those, this is a base of 2. This is a base of 4, from 0 up to 4. And this is a base of 4 up to 9 is 5. So what I'll have you notice is this is different from last time. Last time up here they said equal lengths. These are equal length subintervals. And that's why the 2 was the same every time. The base was always 2. The base was always 2. When you do that subtraction in the beginning and divide to find the width or the base of each rectangle, you're doing equal subintervals or intervals of equal length. We are not doing that in number 5. In fact, it makes it a little bit easier for us because they tell us exactly what intervals to use. I kind of like these. All right, let's continue from there. So that means we're going to do right-hand rectangles. So our integral area is going to be approximated by a base of 2 and a height that we will find in a second, plus a base of 4 with a height that we'll find in just a second, and a base of 5 and a height that we will find in just a second. All right, now it's time. We're doing right-hand rectangles. So we're going to choose the one on the right. You guessed it. Don't use the 2. Next, we'll use between the 3 and the 2. Right? So we're going from here to here, from 0 to 4. We're going to use the one on the right for that one. And then for the last one, we'll use the one on the right. Okay, so throwing those in, we got a 3 here, we got a 2 there, we got a 4 there. And that turns out to be, let's see, 6 plus 8 plus 20 more. We're looking at 34 square units. All right. Switching over to the left-hand rectangles. Same concept, but now we're going to use the 2. That's the left side of this little subinterval. And then for this subinterval, we'll use the 3 because that'll be the height for that subinterval, ignoring the 2. And then the third subinterval, we'll use the 2 and not the 4. All right, so the plans change a little bit. You got to go back in and circle the appropriate values. All right, so same basic concept. So the area is, let's see, same base of 2, but now it's a height of 2. Second time through, the base is 4, the height is 3. The base is 5, and the height is 2. So that equals 26 this time, 26 square units. So I'm guessing that 26 is our underestimate and 34 is going to be an overestimate. So hard to tell without looking at the picture, but sometimes you can make a guess at it like that. All right, moving on to number 6. I think we got kind of the hang of it now. We're looking for equal length subintervals this time. So let's go ahead and let's see. We'll use, how about some red on the left? We're going from 0 to 8 equal subintervals. So first thing we got to do is find the width. So we'll go 8 minus 0 divided by 4. That's going to be 8 over 4, which is 2. And we got to go from 0 to 8. Okay, don't use this at all. There's nothing going on over there. Don't use the 9 and 4. So 0 to 8. Here we go. 0 to 2, 2 to 4, 4 to 6, 6 to 8. All right, if you're doing left-hand rectangles, you will be choosing the left side, the left, and the left, not the right. If you're missing that, here's your first rectangle. The base is 2. And the height is going to be the one that shows up on the left because it says left. Second rectangle. Base is still 2. Right? These are always 2 because they're equal length subintervals. The height for the second interval, the second subinterval, is going to be a 1. The base for the third one will be 2 again. And the base for the fourth one will be 2 again. So then the height would be 2 for this guy and then 4 for the last guy. Put that all together and we get, let's see here, this is number 6. I got a 20. That's 6 and 2 more is 8. 4 more is 12. 8 more is 20. There we go. Very good. All right, next, moving on to part B. We're going to use right-hand rectangles now. What I'll do is I'll go back and I'll erase my circles here. It'll be a little bit easier to see what's going on. So let's see. For my first subinterval, we're going to use the right side, which is a 1. For the second subinterval, use the 2. Third subinterval, use the 4. And finally, we'll use the 5 there. All right, for this one, let's see. It's still a 2 out in front. I'm going to go no parentheses around the base this time. It's kind of a nice look, a little bit cleaner, I think. And then we throw in the 1 and the 2 and the 4 and the 5. 1, 2, 4, 5. Once you get the hang of these, there's really not much to it at all. Somebody might try to factor out the 2 and leave a 1 plus 2 plus 4 plus 5. I guess you could see a multiple choice question where they ask you which of these is equivalent. But ultimately, final answer should be 24 for that one. All right, that's probably enough for this video. Hopefully that's helping. Feel free to go back and practice them on your own. You can pause it wherever you want. Try a problem. See if you can do it on your own. We'll see you next time. Thanks, guys.